Hello, we are Team HelmHUD. I am Michael, this is Hong, this is Vincent, this is Carter. We created a heads-up display for cycling. The display currently shows temperature, speed, heart rate, GPS, and battery. The way it works is by sending signals over Wi-Fi to a router that's based inside the helmet to then update the display. We currently have an environment sensor as well as a thermometer, a barometer, and accelerometer mounted to the bike. We have a heart rate sensor that can be placed on your skin, and we have a GPS module that can read GPS data. The benefits of our project allows you to see all your vital information while not having to take your eyes off the road when you're cycling. The part of the project that I contributed to is the environment sensor with the magnetometer and the thermometer inside. It currently is capable of detecting this magnet and timing how long it takes to register the magnet going by. It uses the circumference of the wheel, which currently is 26 inches, to figure out the speed in miles per hour. The thermometer obviously measures the temperature and humidity in the environment, and it takes the data that it collects, and anytime data updates inside the environment sensor, it then sends it over Wi-Fi to the router, which then updates the display. The environment sensor has the smallest battery, which currently lasts around 2 hours due to all the sensors housed inside of it. I will now pass it over to Hong to talk about the compass.
So the magnometer is the main driving point because it has three-dimensional axes with X, Y, and Z. But the neat thing about a compass is you really only need two axes. As one of them change, especially the Z-axis, by our testing, we can point a cardinal direction, and however, it has to be adjusted based off where you are. We did try to hard code it a little, so with a declination, but that was a little hard, so we just ended up just hard coding the values instead. And Vincent would like to talk about Bluetooth and how much fun he had with it.
But first, I'd like to talk about the heart rate sensor. So the heart rate sensor is this device that I'm holding here in my hand. There's a power button, so if you press that, it'll automatically start up and begin to take readings. So if I just put my finger over the red here, then on the helmet, it should begin to measure my heart rate, which our algorithm for measuring the beats per minute is not very accurate. At least for me, it has a tendency to show my heart rate as being all over the place. I have attempted to synchronize it somewhat to the heart rate sensor on my phone, but so far it remains not very accurate. So if I turn this back off now, I can open things up. And here is the guts of the device. It is really just a Raspberry Pi Pico with a power board for the battery itself and the heart rate sensor stacked on top of it. We wanted to do something using custom PCBs, but we ultimately did not have the time to do so. Which brings us to a personal pain point of mine, Bluetooth. Oh boy. So, Bluetooth was our initial interface of choice for its short-range wireless connectivity. We initially chose it over Wi-Fi because we believed that it would have been simpler, given that it is to an extent, point-to-point wireless interface between devices. We were very, very wrong about that. And I now know from experience why in the industry, almost nobody outside of giant companies make Bluetooth devices. So the Raspberry Pi Pico does have a hardware Bluetooth interface built in, specifically the wireless variant, the Pi Pico W, but actual software support for libraries involving Bluetooth did not exist until about half a year ago at the time of the beginning of the project, roughly a year ago now. And the result of that was that the documentation was sparse the libraries were incomplete, and it was quite a mess for us personally to deal with it. We ended up switching from C to MicroPython as our programming language of choice because at the time it looked like the MicroPython libraries for Bluetooth were more feature complete than C. But it turns out that MicroPython itself was also quite the pain point for us. And I ended up spending personally about half a year just trying to get a single message to successfully send. And even once we did get two-way communication working with MicroPython Bluetooth, it had this strange issue where after some arbitrary amount of time, the Bluetooth interface would disconnect silently, with both devices still continuing to act as if they were connected, where they would attempt to send data to each other, but neither of them would actually receive that data. In the end, we ended up switching to Wi-Fi, as Michael mentioned, and what used to be hundreds of lines of code ended up being 5 lines of code to connect to Wi-Fi and do the same things that we were trying to do over Bluetooth. So with that, let's move on to the GPS.
Hello, I'm Carter Edgington, and my part of the project was working on the GPS and getting it integrated within the project. So the GPS module came with some libraries on it. Unfortunately, those libraries were made for the Raspberry Pi, not for the Raspberry Pi Pico. So there were some incompatibilities, like the SM bus library that the Raspberry Pi uses does not exist in MicroPython. So I spent the entire time trying to get this library moved over to be compatible with MicroPython and the Pi Pico for this project. The GPS itself is not very good. It's just from how small the antenna is. I have to go quite a ways outside in order to get a good signal, especially within the university, which I think is potentially maybe like a reception sinkhole for GPS. But other than that, I think things went fairly smoothly regarding the GPS integration into the project. And,
Okay, I'll go ahead and show the inside. This is the main server Raspberry Pi Pico that is controlling the display and connected to a battery. And yeah, I think that is good on the engineering behind it. Now we will go ahead and record a demo of it working. So for our product demo, we're going to go ahead and put the camera inside the helmet while I get on the bike and Vincent holds the heart rate sensor. So the first thing that should have been updated is the temperature. Now, as I begin to ride, you will also see the speed go up. Then in the bottom right corner, you should also see Vincent's somewhat inaccurate heart rate update as well. Now, we're currently indoors, but our GPS module is only capable of getting a signal outdoors, so our latitude and longitude is just going to appear as blank dashes for now. And as you can see, or better yet can't see, the lens we're using makes it impossible to view beyond the display, so a future version of the project would benefit from a projector that we could actually adjust the focal length of.